Differential equations, 1997, question 10b. So this is type 2a, which is linear motion, so our real world questions. And here we have a particle moving in a straight line and undergoing a retardation of 0.04 v cubed meters per second squared, where v is its speed. We're told the initial speed of the particle is 25 meters per second, and we want to know what is its speed when it has travelled a distance of 49 meters. So for the first part of the question, because we're given velocity and we're looking for distance, then we're going to be saying our equation for acceleration will be v dv ds, because we have velocity and displacement. So what do we know about A? Well, we know its acceleration is a retardation of 0.04 v cubed. So because it's retardation, that means it's slowing down. So that's going to be minus 0.04 v cubed for the acceleration is equal to v dv ds. So we're going to bring our v's and our dv's to one side and anything else to the right hand side for ds. So therefore, if I divide across by v cubed, I'm going to get v over v cubed times dv is equal to minus 0.04 ds if I multiply both sides across by ds. And v over v cubed can be written as 1 over v squared. And therefore, if I'm going to integrate both sides, I'll need to change 1 over v squared to v to the power of minus 2. And then I need to write down, well, what are my limits? So what do I know at the start? And what do I know at the end? Well, my start limits state that if the initial speed of the particle is 25 meters per second, so the initial speed, so v is going to be 25 meters per second at the start, and therefore it won't have moved any distance at that point, so that's going to be 0 for s. Then we have to find the speed, so v is what we're looking for, when it has travelled a distance of 49 meters, so s is going to be 49. So again, end limits are always my upper limits, and start limits are always my lower limits. So if I integrate v to the power of minus 2, I'm going to add 1 to the power, divide by that new power, and sub in my limits. And if I integrate minus 0.04 with respect to s, then that's going to be 0.04 s. It's in the limits of 49 and 0. So that's going to be the same as saying 1 over v And now if I sub in my limits, so it's upper limit minus lower limit, so that's minus 1 over v minus 1 over 25 is equal to minus 0.04 times 49 minus 0.04 times 0, which is obviously going to be 0. And therefore on the left I have minus 1 over v plus 1 over 25 is equal to, so that's going to be minus 49 over 25. Okay, so let's simplify that. So that's going to be 1 over v is equal to 1 over 25 plus 49 over 25. So therefore that's 1 over v is equal to 50 over 25. So 1 over v is equal to 2. In other words, v is going to be equal to 1 over 2, which is 0.5 meters per second. So we had 5 marks for setting up our integrand, 5 for integrating, and 5 for our answer. So the second part of the question then, if we go back, says find the time for the speed to reduce from 25 to 15. So this time we have velocity and time for our limits, which means we're going to have to take our equation for acceleration and let it equal to v or dv dt. So for part 2, we're saying A is equal to dv dt. But we know that the acceleration is minus because it's slowing down, so it's retardation. And that's equal to dv dt. So again, if I rearrange that, so divide both sides across by v cubed, so I get 1 over v cubed dv, multiply both sides across by dt, so I get minus 0.04 dt, and then I'm going to integrate both sides, so 1 over v cubed I can't integrate, so I'm going to have to write that as v to the power of minus 3. And now if I integrate, I need to look at my limits. So what do we know at the start and what do we know at the end? So again, if I go back to the question there, at the start, the time to reduce from 25 to 15. So the starting velocity is 25 meters per second. The starting time will be 0. The end time is what I'm looking for, and the final velocity was said there, it was 15. So t will be t. So again, my end limits are my upper limits. My start limits are my lower limits. And if I integrate v to the power of minus 3, I'm going to add 1 to the power, divide by that new power. And then if I integrate 0.04 with respect to t, I get minus 0.04 t, and my limits are t and 0. So v to the power of minus 2 is the same as saying 1 over v squared, and then that's times minus a half. So that's going to be 1 over 2v squared, then the limits of 15 and 25. So now subbing in my limits, I have minus 1 over 2 times 15 squared minus 1 over 2 times 25 squared. And that's equal to 0.04t minus 0. And then if I simplify the left-hand side there, so that's minus 8 over 5,625 is equal to minus 0.04t. So therefore t is going to be equal to 8 over 225 seconds, or you could write that in decimal form, which would be 0.036 seconds either. Okay, so again, 5 for setting up, 5 for integrating, and 5 for our answer. So 30 marks altogether for your question.